For 8A, we're going to add, subtract, and multiply with complex numbers, and then we're going to do some division conjugate work in the second half of it. So far, everything you've done in Algebra 2 is real numbers. Numbers like you see there, 5, 1/2, 2.75, even numbers like the square root of 2 and pi. Those are all real numbers. You could place them somewhere on a number line, right? That's not going to be the case anymore, okay? Today's lesson is going to deal with an imaginary number, an imaginary unit, if you will. And let me show you how we come up with this. So we're going to solve x squared plus 1 equals 0. If I were going to solve that for x, what would you do first? Subtract 1. So if I take away 1, I get x squared equals -1. What do you do next? How do you solve for x? Why are like 5 of you never looking at me? Stop doing whatever you're doing that's not math and start paying attention up here, or you're going to really struggle on this lesson. Okay. You have to square root. Okay, so here's the issue. When you square root this, you're taking the square root of a negative number. Can you multiply a number by itself and get a negative? No, right? You can't go, the square root of -1 is -1, because -1 times -1 is +1, right? So mathematicians back in like the 1540s, a very long time ago, wanted to be able to solve an equation where you could do this unsolvable stuff and keep going, keep solving. So what they did was they came up with the imaginary unit, which we call I, okay? I is not a variable, it's a number. Weird, right? I represents a number. Here's what it is. I is always the square root of -1. So if you think about that, the square root of -1 squared, or I squared, equals -1. Okay? So whenever you see an I squared, that's going to equal -1. Whenever you see an I, it's going to equal the square root of -1. All right? So here's how they figure it. If I have the square root of a negative number, I'm going to do what we did in the last couple sections, and I'm going to break that down into two separate things. I'm going to break it down into, it's right here, the square root of -1 and the square root of a. That means I get I, the square root of -1 is I, times whatever the square root of a is. Okay, so you're just kind of breaking it into two things and then simplifying. I'm not talking to you, Siri. I'm not talking to you. She's on it, though. Okay, so let's just try this with these problems. If I have the square root of -36, I can think of that as the square root of -1 times the square root of 36. What is the square root of -1? I. What is the square root of 36? 6, right? So this is equal to 6i. And now I told you I is a number, but we still put it how we would with variables. We usually put the I at the end. So this is 6 times I. Okay? So what would you break the square root of 25 into? -25. That would be 5i. It's the square root of -1 times the square root of 25. That is 5 times I. What does letter C become? 10i. Right? The square root of -1 and the square root of 100 is 10i. Are you ready for the best joke you've ever heard? It's like some of your girlfriends. A perfect 10, but she's imaginary. That's Mrs. Price's joke. That's not my joke. That's her joke. I know, it's mean. That's why it's not, can't be mine. I don't like being mean. I did not. I was not talking about anyone in this room. No, that's Mrs. Price's joke. It's hers. Okay. I'm totally recording right now, too. That's a terrible idea. Okay. I will have to edit it. Okay. Letter D. I'm not going to. Letter D. Now, this one's a little bit different. Think about how we could break this down. Okay, you can take the square root of -1 times the square root of 8. But what is the square root of 8? Right, the square root of 8 is rad 4 times rad 2, or 2 rad 2. Okay, so let's think about what we have here. We have the square root of -1, we have a 2, and we have a rad 2. What does that simplify to? 2i rad 2. Okay, this is our I. We're going to stick that right behind the whole number 2. 2i rad 2. What's letter E going to be? I rad 3. Can't break the square root of 3 down at all, but you can take the negative out of there. So I rad 3. Yes, ma'am.
If we do regular I instead of
Yeah, I'm trying to think if that's going to be, as long as I can see the dot, so it doesn't look like the number 1. Yeah. Okay. So, when dealing with complex numbers, you will have what's called standard form. It's always standard form, right? Standard form with everything. Standard form looks like this. It'll be the real portion of your answer, right? This is the real part of your answer, is just the I. And then the imaginary part is is the A. The imaginary part is whatever has the I with it. So BI, whatever that is. It could just be an I, it could be a number with an I, but that will be your imaginary part. Notice, those are not like terms. If I have 2 plus 3i, I don't make that 5i, okay? That I is a number that's changing my 3. I can't just add something to it because you have to divide, or you have to multiply them first and then add. And because we can't multiply them into something simpler, then we can't add them either, okay? So you would just leave it like that, and you just always write it in the order that you see for standard form. So it's going to be the integer first, the real part first, and then the imaginary part after it. -10 minus 7i, 2 plus 3i, -4 plus 6i, okay? It always comes with the I at the end. Okay, so complex numbers, it's kind of like, they say something's like an umbrella term, right? It's the big picture. It's the umbrella that covers everything. Basically what we're saying is you have complex numbers, A plus BI. There's 2 parts to that. There's the real part, which means basically your number in front of the I is 0, and then your I goes away, okay? So you could have just a number here, like 5, or the number pi, okay? Technically, that's a complex number, but it's a real number also, okay? Or you could have the imaginary. If it's a 0 plus BI, this is your imaginary part of it. So something like 5i or something like -2i, right, would be the imaginary portion of it. The complex is when you put them together. So 5 plus 6i, right, would be a complex number. Now, that's also considered an imaginary number because it has the I in it. You can call that an imaginary setup. So just to be clear, everything is like complex numbers, but then within that, you'll have imaginary, which can be any of these type of setups, or real numbers, which are anything you could put on a number line, okay? Okay, so let's do some of the work with this. The first thing we're gonna do is we're gonna add and subtract these. And this should be very simple. You guys know how to do this. Just think of, instead of an X being there, it's an I that's there, okay? It's the same idea as what we do when we add with variables involved, because we do still need them to be like terms, if you will. So if there's an I with it, anything else with an I can also be added or subtracted to it. So if we're going to add this, you will take 4 plus 5. We'll take our real number portions of it and add them together. 4 plus 5 is 9. And then we'll take the imaginary portion. Negative 3 plus negative 6, negative 3i, sorry, plus a negative 6i would be what? Add them together would be a negative 9i. Is this standard form? The real part first, the imaginary part second. You cannot combine them. That is not 0i. Okay, don't subtract those. That is your answer, just how you see it. Yeah.
Doesn't the plus make the 6i positive?
No, because we're saying negative 3i plus negative 6i, right? If it's minus a negative, then it would become plus a positive. Okay, letter B. Now we're subtracting. And remember, with those parentheses there, essentially you're distributing that subtraction to both things. So I'm saying 5 minus 4 is 1. And then 2i minus a negative 3i is what? 5i. So this becomes plus a positive. 2i minus negative 3i becomes plus a positive. So that's 5i. So it's plus 5i. And you get that as your answer, 1 plus 5i. All right, look at letter C over here. Negative 2 minus I minus 5i. What does that become? Negative 2 first, right? You got to keep the negative 2. And then negative 1i minus 5i is a negative 6i. So that will be your simplified form. The parentheses there aren't really doing anything at all. Yep, because we're still just subtracting the 5i. Now, if there was that negative 5i out in front, you'd be distributing the negative 5i, right? Which is more what we'll do here. So that's adding and subtracting, pretty straightforward. Make sure that you just are paying attention to negatives because that's where the hiccups tend to come on those. Example 3, now we're gonna start multiplying them. And here's where it gets a little bit fancier. Something to remember. If I take I times I, it will be I squared. Okay, and remember, I squared, we had that up here, didn't we? Yeah, see right here? I squared equals what? Negative 1. You're basically saying the square root of negative 1 times the square root of negative 1. So whenever you see an I squared, you can replace it with a negative 1. Okay, so keep an eye out for that. Not this kind of I. This kind of I. I squared is negative 1, okay? Okay, so if I'm going to multiply this, 2i times 5i, what do I get? 10i squared. So what is 10i squared? Negative 10. Guys, do you see what just happened? You just multiplied positive numbers, and you got a negative answer. Have you ever done that before in your life? Nope, sure haven't. Kind of crazy, right? Okay, letter B, 4i, and we're squaring the whole thing. Notice the parentheses around both parts of that. So essentially you're thinking of this as 4i times 4i. What is that? 16i squared. And what do you get? Negative 16, right? I squared is negative 1. Negative 1 times 16 is a negative 16. Now look what you did. You just squared a number and you got a negative answer. That never happens. Isn't that cool? Okay. Letter C. What do you suppose you're going to do here? Distribute, yes. So let's distribute this. What do you get? 3i times negative 5. Negative 15i. And then 3i times 2i plus 6i squared. Okay, so now I have negative 15i. Then what? I squared is negative 1, right? Minus 6. Okay, but Now look what happened. Are we in standard form?
No.
No. So what you want to do is you want to flip-flop those. That is the same as -6 minus 15i. Okay, so put it in standard form. Your I should always be at the end with your real number at the beginning. Okay. Questions on that? Okay, go up to the top here. Letter D. What do you do with this? A binomial times a binomial. Foil it. Yes. So if we foil this, we get -4. What does this become? -8i. What does this become? -3i. And then -6i squared. Okay, so now look at what happens here. There's some i's, but there's also the I squared. So if you simplify this a little bit, it's -4. If you want to just combine your i's right now, you can. What would that be? -11i. And then what is this? +6, right? That's a -6 times a -1. -6 times -1 gives you a +6. So you have -4. You don't need to rewrite this. I'm just writing it neater for you. This is what we have so far. What is your final answer? Right. Combine like terms. -4 plus 6 is 2 minus 11i. Okay. If you're foiling, I should absolutely see work from you on that. Don't do that in your head. That doesn't go well in your head. Show your work. Okay. Okay. This one's special. This one's really special. Notice what we're looking at, -4 plus 5i and -4 minus 5i, and we're going to multiply them. So we're going to FOIL. What do you get first? That's a +16. Outside, I'm going to give you binomial Benny here. Plus 20i. I think I've told you about him, have I not?
No.
Binomial Benny. It makes a cute little face. I'll show you when you FOIL. So first, outside, inside, this is his nose. What do you get? -20i. And then last is his other eyebrow. And you get a -5 times 5, 25, I times I squared. See binomial Benny? This is his nose, his mouth, his eyebrows. He's got a unibrow. And then some. Anyway, okay, so we have foiled these two. Now if we simplify, look what happens. It's fantastic. You have a 16 here. What does this equal?
25.
A +25, right? Plus 25. So you have 16 plus 25. What does this equal? 0. 20i minus 20i is 0. So your answer is 16 plus 25, or 41. You just took an imaginary set of binomials, multiplied them together, and you got a whole number answer. Fantastic. So it is possible when dealing with imaginary numbers to get a real number answer, right? That's what we just did. We got a real number from working with imaginary numbers. Isn't that fantastic?
No.
I think it's fantastic. I like it. Okay, something I just want to point out to you real quick. A little side note for you. If you take I cubed, what could you simplify that to? Not -1. You could break this into that, right? I squared times I is the same as I cubed. What is I squared? -1. So if you have an I cubed, it's the same as saying a -I, right? What if you have I to the 4th power? That's like saying I squared times I squared. What is I squared? So the product is 1, right? Basically, you're saying -1 times -1 which is a positive 1. So if you ever see an I to the 4th, that number is 1. Isn't that crazy? That's so funky. I love it. I just love it. I mean, maybe. I mean, it can be. You need to understand the concept, right? You need to understand that an I squared is always negative 1. So if you know that, then you break it into the pieces. Yeah, Naomi.
Isn't there like a pattern?
You could see, so if I kept going, like I to the 5th, right? You would have I squared times I squared times I. So that would be negative 1 times negative 1 times I, and you would just get I, right? And then if you went one further, I squared times I squared times I squared is negative 1 times negative 1 times negative 1, which is negative 1. And then it starts all over again to bring you back to the negative I, and then the 1, and then the I, and then the negative 1. Yeah, it would just keep cycling through those 4. Okay, that would have been your day 1 lesson, the lesson that we would do today if they hadn't changed our blocks on us. Do you feel like you need a little break before we move into day 2? Yes. Okay, let's pause. All right, here we go. 4-8B is conjugate. So the first thing, come back to me. Got your notes out, ready to go? Here we go. The first thing you need to know is what conjugates are. And you actually just solved a problem right here with conjugates. And do you remember how nicely that one came out? You got a real number answer, right? Conjugates are going to be when you have 2 binomials. Remember when we did difference of squares? And we would take something plus something and something minus something to get our difference of squares? That's what this looks like, right? The difference is, it's not a difference of squares, it's a sum of squares, because when you multiply an I times an I, that negative becomes a positive, right? So it's gonna feel similar to difference of squares, but it's a sum, okay? Be careful with that. So basically what happens is this. This is the rule. You take your A value and your B value and you just square both of them and you add them together. So if I look at this problem below, I take 3 and I square it. I take the 4 and I square it and I add them together. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. So this 3 minus 4i times 3 plus 4i will always equal 25. Okay? It's basically the sum of 2 numbers squared. Okay? So when we do these, couple things, we're dividing. Okay? You use conjugates when you're doing division. I'll show you why. The first reason is we can't leave I in the denominator. Do anyone know why we can't leave I in a denominator? Not because it's imaginary. It's a square root, right? We said no radicals in the denominator. You have to rationalize your fraction so that it's not got a denominator with a radical. So that's thing number 1. When you are dividing, do not leave I in a denominator, ever, okay? It's not allowed. Number 2, what you're gonna do is you're gonna multiply by the conjugate of your denominator. So whatever your denominator is, you will multiply by the conjugate of that to simplify your answer, okay? So let me show you on this first one, and you must show your work on these, okay? There's a lot going on here. Show me what you're doing. All right, here we go. Oh no, we're good. I thought I was missing something. Oh, I see. Okay. When you set this up, you have an I in your denominator right now, meaning this is not the simplest version of what we can do. So you're going to multiply the denominator by its conjugate. Now, this one maybe seems a little tricky because it's not in the same format as this, right? It's not an A plus BI. It's just a BI. So what is your A right now? Not the 9. For this number, what's your A value? 0, right? So essentially you're thinking of this as 0 plus 3i. You don't even need to write this down right now. What would the conjugate of that be? 0 minus 3i. So the conjugate of 3i, 0 minus 3i is negative 3i, right? So you don't need to set it up like this. You just need to multiply by the conjugate, which would be the opposite in this case. If there is no a term out in front, then your conjugate is going to be a negative 3i. So this is just like rationalizing the fractions with radicals. It's just your radical doesn't look like a radical right now. It looks like the letter I. Okay? So if we multiply by a negative 3i on top and bottom, then work it out, see what we get here. You're going to distribute. Okay, so on top, right now, you have a negative 27i. What's negative 3i times 12i? Minus 36i squared. Okay, what do you have on bottom? 3i times a negative 3i is what? Negative 9i squared. Okay, now let's simplify this a little bit. You have on top a negative 36i squared. What is negative 36i squared? A positive 36. So if we're going to write this in our standard form, that 36 is actually going to come first because that's my real number, right? Negative 36i squared is just a positive 36. Then you have a negative 27i. What's negative 9 times I squared? A positive 9. You're doing negative 9 times negative 1, right? I squared is negative 1, so negative 9 times negative 1 is a positive 9. Do you see anything else you can do here? You can simplify that. Everything's divisible by 9, right? So if I divide by 9, I get 4 minus what? Minus 3i, and your 9 went away because we divided everything by 9. That is your answer. Yeah.
Okay, I get it, but like, 36 minus 27i, how is that divisible by 9 if we don't have an I in it?
Remember, multiplication and division, you can still multiply or divide. Think x's, right? If I have like 27x over 9, right? We can still reduce that fraction and reduce that fraction as long as we're reducing them by the same amount. So you kind of treat this like a variable. It's not a variable, right? But we kind of treat it like a variable because you can multiply and divide in any order. So I could multiply these first and then divide, or I could divide them first and then multiply because commutative property, right? You can do it in any order. So you're still allowed to reduce that fraction and set it up as 4 minus 3i. Okay?
But if 9 has an I on it, then would you still...
If 9 has an I on it, you can still reduce it. Then these i's would also go away. But you wouldn't be able to reduce... You can't get rid of the I here if there isn't one... Are you seeing that? Let me change my colors. You can't get rid of this I here if there isn't one here, so you'd have to break it into two separate things. You'd have to go like 36 over 9i minus 27i over 9i. That can be 3. This has to be 4 over I. The I has to stay with it. You guys got so many good questions. Okay. Letter B here. What do you do with this? Brett.
Are you recording all this?
I am. Yeah, I know. There's a lot going on here, huh? What do you do here? If you have an I in your denominator, you multiply by what?
minus 3.
3 minus 4i, the conjugate of our denominator. So right now, it's 3 plus 4i. The conjugate is 3 minus 4i. So you're going to multiply by the conjugate over itself. Just like that. Okay? Which is lovely for the bottom number. Let's look at our bottom right now. Remember the formula for this? And if you don't remember the formula, you can FOIL both. It just takes a lot longer. But if you remember the formula, we said all you have to do is square the first one, square the second one, and add them together. Right? That was when I told you what the conjugates were, right here. You take your first number, you take your second number, you square them, and you add them. So whenever you multiply conjugates, that's all you got to do. Square them, add them together. So this one is actually the same numbers that we had on that first one. 3 squared is 9. 4 squared is 16. So we get 25 when we multiply those together. Okay, so that's your denominator, 25. Okay, your numerator takes a little more work because they aren't conjugates. So you can't just square the first, square the last, right? You have to FOIL it. So FOIL this top one. This is going to be a little bit longer. So first is 15. Outside would be a negative 20i. Inside is a negative 6i. Last is what? Negative 2i times a negative 4i is a positive 8i squared. Okay, now simplify. What?
So does that mean the 8i squared would be negative 8?
Yes, 8i squared, this right here, is negative 8, right? Because I squared is negative 1. 8 times negative 1 is negative 8. So we have 15 minus 8 on top. So that's going to be 7. Then we have negative 20i minus 6i is what? Negative 26i. And that's over 25. Okay, now you may leave it like that, or if you like it better, how we were just talking, you could split it. Oops. Okay, either one of those is fine. I personally would just leave it as the top one, but you may, if you like it as 2 separate fractions, you can do that. Okay, one or the other, don't do both of those, so you don't need them both. Questions on that? What? Who's talking? Clara, yeah.
Why is the bottom just 25?
So when you multiply conjugates, remember conjugates are, if you look at this, 3 plus 4i,
Oh, wait, never mind, actually.
and 3 minus 4i, you square the first, square the second, and add them together. You can always just FOIL them too. If you want to FOIL it and work it out that way, it will work. It's just more work to do. It's all good. There's a lot going on. Okay, last thing here. With complex solutions, now you're going to be able to solve for x even when you have a negative radical, right? Up until this point, you haven't been able to do that because you didn't know how complex numbers worked. Now you do. So now you can find answers for these using the different methods we've used. So we're going to do solving by square roots, and we're going to do solving by the quadratic formula. This should feel very familiar to you. Your answers are just going to look a little bit different. Okay, so this first one, if we're solving by square roots right now, what's the first step? Some of you did this wrong on your quiz, so pay attention. Subtract 75. Some of you tried to divide by 3 first, and that didn't go well. Take away 75, so I get 3x squared equals negative 75. What do you do next? Now divide by 3. So x squared equals negative 25. Okay, now what? Now you square root. What happens when you square root in an equation?
You get rid of the square and the x, and you get...
How many answers? There we go. Plus or minus, right? When you square root both sides, You get plus or minus. So x equals plus or minus, what is the square root of negative 25? 5i. Okay? Do you know what?
Wait, how come there's no any quiz? I figured out my mistake after I finished answering, but I still got the right answer.
Oh, well, maybe you divided and then moved things over and then square rooted? Because you still would. Yes.
And then after I realized I
Yeah. What's up, Amara?
How come there's not any eyes, but you put one?
Because we just took the square root of a negative number. So think of this as the square root of negative 1 times the square root of 25, right? Square root of 25 is 5. The square root of negative 1 is I. So whenever it's the square root of a negative number, you should have an I. Okay? Okay, letter B. What do you do first? Solving by square roots. Take away the 36. So 2x squared equals negative 36. Then divide by 2. So x squared equals a negative 18. What's next? Take the square root. And when you take the square root, what happens? Plus or minus. Now, the square root of negative 18 is like the square root of negative 1, which is I, right? Times what? The square root of 9 times the square root of 2, right? So you have the square root of 9 is 3. The square root of negative 1 is I. So 3i times the square root of 2. Two answers, plus or minus, okay? Questions on that? Okay, last two. This is it. Oh, my A went away. This was supposed to be A. So now using the quadratic formula. You bet on that?
Yeah,
Wow. Okay, so the quadratic formula. X equals a negative b, so that's a positive 1, plus or minus the square root of b squared, so negative 1 squared. Don't forget the parentheses. A lot of you forgot parentheses on the quiz and then got it wrong because you get the wrong number when you don't put parentheses. B squared minus 4 times a times c all over 2 times the a value. I say all over because that whole thing is over the 6. Some of you only put the 6 under the radical. It's over the whole thing. Naomi.
In my work, would I get a point out if I didn't put the parentheses? Because in my head, I see it as just regular point.
No, as long as you're getting the right answer, that's okay. Yeah. Okay, so here's the deal. At this point, you would typically just plug this into your calculator, right? So if you plug that in, or you can do the mental math of it, what do you get? 1 plus or minus the square root of negative 23, right? 1 minus 24. That's a negative 23 over 6. Can you simplify that further? Yes, you can. You can take an I out of it, right? So this would be 1 plus or minus I rad 23 over 6. Because I want people to see where I'm coming from. Okay? So those are your two answers. 1 plus I rad 23 divided by 6. 1 minus I rad 23 divided by 6. Okay? Okay, I want you to try the next one by yourself. That'd be good. This one isn't terrible. You could do this one in your head. You can do it in your head. But yeah, if you want to do it with a calculator, that's fine. Okay, work this one out. What do you get? Work it out. So it's x equals, hey, work this out with me. Negative b, so a positive 4 plus or minus negative 4 squared minus 4 times 1 times 5, right? B squared minus 4ac. By the way, discriminant. What is it? People just like went poof on the quiz. B squared minus 4AC, right? That's your discriminant. Discriminant. Okay, so this is over 2 times 1. All right. Chill. What did you get under your radical? -4. So it's 4 plus or minus the square root of -4 over 2. Okay, simplify that again. What is the square root of -4? Gentlemen. Hey, be done. What's the square root of -4? 2i, right? This would be 4 plus or minus, the square root of 4 is 2, the square root of -1 is I. So like that, over 2, keep going. Everything there is divisible by 2. So 2 plus or minus I divided by 1 is just 2 plus or minus I. So this is your answer. Okay? Now here's what I want you to see. In all 4 of these problems, right here, right here, right here, and right here, you got 2 complex solutions, right? Remember how we said if your discriminant, this number, this number, this number, this number, if it's a negative, you get 0 real solutions. Excuse me, I am talking. Listen. 0 real solutions, right? That doesn't mean 0 solutions. 0 real solutions. We got imaginary solutions just fine, right? Those are complex solutions. So just keep that in mind. Just because it has a negative radical doesn't mean there's no solution. It means there's no real solution. There are complex solutions to be found. Okay.